Hello friends, we are going to continue the next topic in the compass surveying, that is forward bearing and back bearing. We have already seen about the whole circle bearing and reduced bearing or the quadrantal bearing. Those concepts will be applied in the problem, but if it is in the kind of traverse, then we have the term forward bearing and the back bearing. And what is forward bearing? What is back bearing? When it is a traverse from one point to another point, if you carry the instrument, say on the point A you are holding the compass, right? Then you have to move towards B, then you have to determine the angle with respect to the compass. So you will get the bearing, right, with respect to north. All is the direction of north will vary from point to point? No, if the north is in this direction, anywhere else the north will be the same direction, right? So that has to be maintained. So from the north, you are able to get the bearing of each line. So from A to B, if you get a bearing, that bearing is called the forward bearing. It is forward. You remember, like forward, right? Then to check the bearing, you are placing this compass at the station B and look back the A. You will get another bearing, say BA. This BA is called the back bearing, right? So forward bearing, back bearing is of the same line, but the position of the instrument is different. Right? The line AB will have both the forward bearing and the back bearing. Forward bearing from A, back bearing from the B. So AB, BA. So this forward bearing minus back bearing or the back bearing minus forward bearing must be equal to 180 degree if the area is free of any magnetic particles or it is free from local attraction. Then the forward bearing minus back bearing or the back bearing minus forward bearing must be 180, right? So that is this bearing. Say for example, if it is 120 degree and this is 300, so 300 minus 120 degree is 180 degree, right? So if it happen, then both the station can be considered as it is free from local attraction. The readings taken from those stations also free. So the forward bearing from here, from B to C, again it is a forward bearing, right? It is forward. So that bearing will also free from local attraction. Similarly, you will get the forward bearing, back bearing, forward bearing, back bearing, forward bearing. It is open traverse. It starts from A, it move on towards another point, it end somewhere else. Right? It can be checked in different way. Whether we are proceeded in a right way or that. Between these two, we may have a check line and we can check it. But in the closed traverse, it may be of three-sided traverse minimum and more than that. N number of sides we can have, but the starting and the ending will be same. The traverse may be clockwise or anti-clockwise also, right? So both the way it is possible. So please have it in mind. Say for example here we will consider the point A, B, C, D, E, right? So here the traverse is clockwise from A to B, B to C, C to D, D to E and E to A. Again it gets close to the starting point. It may be also A, B, C, D, E. Anti-clockwise. Both the way it is possible. Right? It depends upon the terrain and depends upon the instrument, depends upon the surveyor. Right? So both the cases are possible. So how we can check whether we have done the closed traverse right or wrong? You are able to get the bearing of the line AB, BC,
EA. I have marked here all the 4 bearing alone. If you mark the back bearing also, you are able to get the included angle of the traverse. Each angle you can obtain. If the summation of the angle, if you get, it can be checked whether the traverse is right, we have conducted rightly or not. How we can check? If 2n minus 4 into 90 degree. Here the n is the number of sides. For say example here it is 5 sided. 5 into 2, 10 minus 4 is 6. 6 into 90 is 540 degree. If all the included angle what we have obtained after calculation, if you get sum it up, angle A plus angle B plus angle C plus angle D plus angle E, if it is 540 degree, then the traverse is right. If it is less than or greater than, somewhere else the error may happen. The error due to the instrument level, handling error, or by the local attraction also, right? So this can be checked. So if it is not happen, then the included angle can be corrected with, after correcting the included angle, we can correct the bearing. It is one type of method. Otherwise, by the standard reading, what we have obtained the 4 bearing and back bearing in the field, if you make the tabulation, if you check the 4 bearing minus back bearing in all the line, if there is any deviation in any line, then we can find there is a change. That correction can be applied to the bearing, then we can calculate the included angle, right? If you are able to measure all the distance also, angle, then you are able to get the area of the particular land. So when the area becomes large, the compass surveying is supported or it can be used. Chain, we can measure the linear measurement, but not direction. It cannot give the direction. So the compass can give the direction and it can go for a longer area also. So compass surveying can be used, right? Now we will discuss the problem. Right, this is the problem. We have started with that. The line AB, BC, CD, DE, EA. It is a closed traverse. So it start with the A and end with the A. So here the bearing are all given in the reduced bearing or the quadrantal bearing. So I here try to solve with this quadrantal bearing itself. You may convert to a whole circle bearing also, but I am going to try to solve here. Right. Easy way of solving such type of problems, first draw the diagram with the given data. See, for the line AB, the 4 bearing is south 37 degree, 30 minutes east. So you mark the north, this will be the south. From south, it is 37 degree, 30 minutes, you draw up a line. So that is the 4 bearing AB. Similarly, next 4 bearing DC, it is south 43 degree, 15 minutes west. From B, south west 43 degree 15 minutes, drop a line. And for then CD, north 73 degree 0 minutes west. So to mark the north, it is northwest. So north west, from north towards to west, it is 73 degree, drop a line. Then mark the north, next line is D, north 12 degree 45 minutes east, right? So 12 degree 45 minutes towards east, drop a line. Then mark the north, it is north 60 degree 0 minutes east, so exactly 60 degree. So you have to think here, if the line 4 bearing is southeast, the back bearing must be northwest. See, it is southeast, it is northwest. Similarly, all the bearing will be in the opposite direction. So one more check you have to see, if the 4 bearing and the back bearing must be of the difference of 180 degree I have mentioned. In reduced bearing, how you can check is, both the 4 bearing and back bearing will be with same theta, but the direction will change. But next see, here 43 degree 15 minutes, but here it is 44 degree 15 minutes. So there is some error or instrumental error, whatever may be, or local attraction. Here also 73 degree 0 minutes, here 72 degree 15 minutes, there is error. 12 degree 45 minutes, 13 degree 15 minutes, there is error. 60 degree, here 59 degree, 1 degree difference. But the one and only line AB is free from any error. So the reading mark with respect to A and B, station A and B are free from error means the forebearing, back bearing, and this AE or the back bearing EA. This also the right one. Next is from the station B to C. That is also right. You can have that in mind. So this fully is right, this is right, and this is right. To check that we can correct these bearings and we can check with this, or we can correct these bearings and check with this. Both the way it is. But here the problem what they have asked is determine the right included angle since there is an instrumental error in the measuring. That was the problem. Just you have to determine the included angle alone. No need to correct the bearing. Right? So, how to determine the included angle? We required this angle A, angle B, angle C, angle D, angle E. Right? So, these are the things required. How you can determine angle A? Already a small portion, that is forebearing of angle A is available. This portion is required. What is this portion from south to west? And the line is AE. AE here for 59. If you add both the things, you will get this angle. Similarly, you require this angle. Here the forward bearing is 43 minutes. The BA or the AB back bearing, it is available. If you add these two, subtract with 180 degree, you will get the remaining. Similarly, if you require angle C, already the forebearing is there and the back bearing is also, back bearing of BC is available here. If you sum it up, you will get the angle C. Similarly, angle D, it is 180 minus these two angles. If you subtract, you will get the angle D. A small variation in the angle E is you require this angle is outer, but this angle is inner. Small portion. So how you can determine? You require this much alone. So total is 180 minus this plus this. So I have written all the things here. Angle A is forebearing of AB plus back bearing of AE. Right? So next is angle B. You can easily remember next is here angle A is predominant. Next is B will be predominant. Forebearing of BC plus back bearing of AB. So there will be B will be repeating. C, CD, CB. Right? Next is here DE, CD. This is the logic behind when you solve with respect to the reduced bearing. Right? So, but the 180 minus that with respect to the diagram you can decide the formula. I hope you will understood. So I substitute all the given data, nothing I have corrected. The forebearing of AB is 37 degree 30 minutes plus back bearing of AE is what? 59 degree. Just take down the theta and have it. Next is angle B. Already I have mentioned 180 minus these two angles. Back forebearing of BC and back bearing of AB. I have written those values. If you solve, you will get 99 degree 15 minutes. Similarly, for angle C, forebearing of CD plus back bearing of BC, I have written the data from the table. Added, I got the answer as 117 degree 15 minutes. Similarly, for angle D, 180 minus these two, you will obtain 95 degree. Angle E, I have given the hint 180 minus 60 degree plus this small angle, you will get the angle E. If you want to sum all these things, you will obtain 541 degree 15 minutes. Whether it is right or wrong, how we can check? Already I have discussed to check 2n minus 4 into 90 degree for n number of side diagram. Here it is again 5-sided polygon. So if you substitute 5, 2 into 5 minus 4 into 90 degree is 540 degree. But what we have obtained is 5, 41 degree, 15 minutes. 1 degree, 15 minutes is extra. So this has to be deducted to all the included angles. How we can deduct? Split the angle into equal 5 parts. 1 degree, 15 minutes divided by 5, you will get just 15 minutes. Subtract all the included angle with 15 minutes. So you will have to 96 degree 30 minutes minus this, 96 15, 99, 117, 94 45, 133. If you sum it all, again you will get the 5 degree, 540 degree. Right? So this is the way of summing. But if you want to correct the angle also, that we will continue in the next thing. Right? Thank you.